Hello, my name is Karthik Pandey and this is my demo 9 video. Here I am demonstrating the final microprocessor with the control circuit. The circuit connects the memory, the data path, the ALU, registers, the next state logic, the control logic. The learning targets for this demo are about to describing the interaction between the control and the data path, apply register transfer logic, and demonstrating the operation of a basic microprocessor. So on the left side of my circuit we have the memory. So there is a ROM. The ROM section stores fixed inputs. The RAM stores the values that can be written during the process. The ROM works as the input data source and the RAM is used to save output data from the ALU. In the middle we have the main, like a heart of the circuit. So that includes the store B register, the accumulator, ALU mini, and the buffer also. Yeah, data bus is where the actual movement and processing of the data happens. On the right side we have the state memory, next state logic, start and stop. Similarly the control circuit, so where from we can like do the control. Here we do 2D flip-flops. So the state sequence, the state memory uses the 2D flip-flops Q1 and Q0. These states control the steps of the microprocessor. The circuit moves through the state using the clock. Each clock pulse moves the processor to the next step. The first state is the ideal. Starting state, the processor loads input B. Next it loads input A and then evaluates to store. So the next state logic creates D1, D0, which tell the flip-flops what the next state should be. The control logic then uses Q1 and Q0 to activate the correct control signal at the correct time. Now I'm gonna run the process using the circuit. So here we know that we have the 8 functions. So what the basically this circuit do, this is the start and stop button, this is the clock, this is the main control happens. So here we have 0 1 2 3 4 5 6 7. These are the storage space and these are the input space. So this is the A and B. So we can choose any input. The output will be only the RAM. So let's save the output on a 5 and we'll choose as the input of just 0 and 1. 0 and 1. This is 0 and this is 1. And enable B is on, the accumulator is on. The function will be 0 and we will do 3 minus 1. Yep, 3 minus 1. The answer would be 2 on the RAM file. Yeah, it's true. Then we will store the next output on a 6. So for that we will use this RAM's input as a 5. So the A is 2 now and we'll use that's the same. So this time we will do A plus B. So we'll change the function. So A plus B, the answer should be 4 on the RAM 6. Oh sorry, my bad, this is 3 plus 2, so yeah, 5. And then the last input we will gonna save on the storage RAM 7. So for that we will gonna use the RAM 6 input, or else we can choose stay with the, or else you can change the output of that, so it will be 4 now. Five. Yeah, that's 4 now. And the next input we're gonna save on that thing. We'll use the RAM CS input, and RAM1 is like that's fine. And we're gonna use the function, the last function, divide a by b, a upon b. So yeah, so our a is RAM6 is 4 and b is 2. So 4 divided by 2 is 2, so RAM should be on 2, the output should be 2. Yeah, that's 2. So this is how the circuit works. This is the main control, this is the main calculation happens, this is the inputs, and this is the RAM. So what basically we did from the last circuit and this circuit, the difference mainly is this thing, the state memory and the next state logic. So firstly we have to manually put the inputs in the ROM, then go to the enable B, we have to change the enable B twice, then we have to change the accumulator, then we have to store it to accumulator buffer, then we spin the clock, and that kind of a manual work we have to do. But now here after doing the sequential circuit, this thing goes very easy. So like mainly my thinking was while building circuit was to first make sure the ALU worked by itself. Then I connected it into the microprocessor. After that I focused on the state machines because the processor needs correct order: load B, load A, calculate and store. Finally I tested the circuit by checking that the first operation could save into RAM, then the second operation could reuse the saved value. The biggest idea I learned from this demo is that a processor is not just one circuit, it is a system of smaller circuits working together. Memory stores values, registers hold temporary data, the ALU performs operations, and the control logic coordinates everything using states and the clock process. So I think that's it from my side. Thank you for watching the video. This completes my microprocessor with control demonstration. Thank you.